So friends, now our next topic is to discuss about the surface tension on liquid bubble. So here this diagram shows a liquid bubble. So in case of liquid bubble, so air will be inside the bubble as well as it will be outside the bubble. There shall be two interfaces. So we will have internal surface of the bubble as well as external surface of the bubble. So this is a peculiar example where we have two surfaces exposed to the air, the inside surface as well as outside surface. So I am going to consider half part of the bubble for better understanding. So if you see here friends, this is the half part of the bubble. So it shows that the inner layer is in contact with the air as well as the outer layer of the bubble is also in contact with the air. So if you look at here friends, inside the bubble there will be some pressure and the outside the bubble there is a atmospheric pressure. So the inside pressure is higher than the outside pressure in order to balance the tension over the surface of the bubble. Okay, so let me show the internal pressure something like this friends. So this is the internal pressure acting on the bubble. We can draw it like this. This is pressure inside. So this is inside pressure, and from outside there will be atmospheric pressure acting on the bubble like this friends. So from outside there will be atmospheric pressure acting on it. So due to surface tension of the bubble, the inside pressure is going to be higher than the outside pressure. Now the surface tension is going to act tangentially over the surface. So the tangential surface tension is going to act on the outside surface like this friends. There are two layers of surfaces, so each surface will have the tension on it. There will be outside tension acting on the surface. So it is going to act normally on the circumference, we can say. The inner surface, which is shown by this line, will also experience a surface tension like this. The value will be same, but it is going to act on two surfaces like this. Okay, so both are same, the value is going to be same, that is sigma. Okay, now the outside pressure, as I have told you, is going to be P outside, that is atmospheric pressure friends, and the inside pressure is Pi. Now this whole system is under equilibrium condition, means the overall forces acting on this particular air bubble across this section are going to balance. So in equilibrium condition friends, the internal diameter I am taking as D for bubble, the internal diameter is D friends. Okay, so here I can write down in equilibrium condition the force acting due to pressure. So force acting due to pressure must balance the force acting due to surface tension. So if you observe it carefully, the force acting due to pressure is going to act on the inner cross sectional area over here, that is inside. So here if I write down that force, that will be the difference of pressure inside and outside friends. So that is, I can write down delta P, that is difference of pressure, times the area. What is the area over here? You see, the area is nothing but pi by 4 times diameter, internal diameter square. So this is the force acting on the cross sectional area which is inside due to pressure difference, and then the force due to surface tension. So we know that surface tension is, that is sigma, is force per unit length, force acting on unit length drawn on the surface here. So if you see in this particular case, so one is external circumference, which is corresponding for the external surface, and the internal circumference corresponding to internal surface. So I can take the diameter approximately same as D. So the surface tension is times. So if I want to find force will be surface tension times length. So length will be 2 times circumference, friends, that is pi D. So we got an equation, find out the value of surface tension. So you'll get from here, if you see here, from here D can be cancelled out because D is there on both sides. So 1 D will be remaining here. This pi gets cancelled out friends. This 4 will go on that side. So I can write down this a simple expression. If I want to find the surface tension, I'll get sigma equal to delta P. This 4 is here, this 2 is here, 2 will come down. So delta P divided by 8 into D. D is there over here. So delta P times D divided by 8. So this is basically the expression of surface tension in case of liquid bubble. So if you want to find the excessive pressure, that is delta P, pressure difference between inside and outside pressure, so that also you can get it from here. Delta P will be equal to 8 times sigma by D. So this is also an interesting outcome. So I can also find the excessive like that. Now we'll solve one problem based on this concept so that whatever we have learned from this theory will be more clear. Okay, so let me read the question for better understanding of it. The pressure outside the soap bubble of diameter 10 mm is 1.0133 bar. Calculate the pressure within the bubble if the surface tension is given as 0.05 Newton per meter of soap solution. So we can easily solve this problem with the help of the theory we have understood. First, let me write down the data given to us. So we have got the diameter of bubble. So that is D, we can say. So diameter of bubble is 10 mm. So we need to convert this into SI units. So it will be 10 times 10 raised to minus 3 meters. Also, they have given us the pressure within the bubble. Also, they have given us the surface tension of the soap solution. So that I'll call as sigma. So the surface tension I'm calling sigma here, and that value is 0.05 newtons per meter. They have also given us the outside pressure, that is atmospheric pressure is given to us. So that I'll write down here the P atmospheric or P outside, and that is equal to 1.0133 bar. Now bar we have to convert into Pascal value, and that is going to be 1.0133 into 10 raised to 5 Pascal. All data given to us has been listed over here. Now let's start with the question, that is we have to find the pressure within the bubble if surface tension is given as 0.05 Newton per meter. So we have to find pressure inside the bubble. So we have already learned that in case of bubble, the difference of pressure is given as 8 times surface tension by diameter. If you see surface tension, it is 0.05 divided by diameter, friends. So diameter here is 10 into 10 raised to minus 3. And if you solve this equation, the value of excessive pressure, that is delta P, you will be getting this value as 40 Pascal, friends. Okay. Now, if you read the question, we have to find the pressure within the bubble. If you see, we have a bubble here. So on the bubble, we know that there is a inside pressure like this, and which is called as Pi. This is called as Pi, friend, and there is an outside pressure also acting on it, which is called as Po. So from outside, there is atmospheric pressure acting, that is Po. So this one is Po, friends, and the inside is Pi. So delta P is nothing but Pi minus Po. So we have got delta P, friends, here. So now I can find out from here, that is Pi will be equal to, from here I can say delta P plus Po. So delta P plus Po will give you the internal pressure. That's very simple. So internal pressure, delta P already we have got, that is 40 Pascal. And then external pressure we have already done. The external pressure is 1.0133 into 10 raised to 5 Pascal. So if you add this value together, you'll be getting internal pressure. So this value is going to be 101,307 Pascal. As we have seen here, by using simple procedure and expression for the excessive pressure, I can easily find out the inside pressure, which is 101,370 Pascal.